And so what we did is we used this concept of limits to make the point really, really close, and then that allowed us to have 2 points. So I'm going to just introduce another term to you. The slope of a tangent in calculus, we sometimes call it that, but it's also called something named a derivative. And so, like today when I'm asking you questions on your homework, if I ask for the slope of a tangent, or I ask for the derivative of something, I'm asking for the same thing. It's just that we kind of use them, there's just a lot of applications of this concept, and we use them in different situations. And also yesterday, or Monday, we said it was the instantaneous velocity. That's also the same thing. Let's write that down so we don't forget. So noisy out there. Instantaneous. Joey, can you, when you get a chance, close that door for me? Okay, and so this derivative or slope of a tangent is based on the slope formula. Okay, so let's just write down the slope formula, and then I'm going to show you the formula that we really came up with on Monday for a derivative. We're going to make the interval really small. Okay, so if y equals f of x, then the average rate of change, which is the same thing as slope, on the interval a to b is, first of all, I'm going to write delta y over delta x. Do you remember what the deltas mean? Changing. And so that what that would mean is we would subtract the y's on top. So how would I find the y value for b? I'd just plug it into the function, right? So wouldn't the y value be f of b? And then I want to find the change in, so minus f of a. So this is the change in y. And then the change in the x's would be b minus a. Okay, so then, from this formula, you're going to hopefully see where the derivative comes from. So if I had 1 point, what we are going to do is we're going to pick an x value. We're not going to do b anymore. We're going to pick an x value, and we want it to be really, really close to a. Okay? And so what I'm going to write is the derivative formula. There's actually 2 ones that you can use. The derivative, first of all, we write it like this. Do you see that like little prime? Do you remember prime from geometry? It's like a little apostrophe, f prime of a. So if you see this f prime, that means the derivative. So the derivative at some certain point, what we do is we make the limit as x goes to a. So we're going to pick a point really, really close to a. So close, we're going to say it gets almost there. Like infinitely close. Like so close that the difference is going to be rounded to 0. Okay. So what I would do then is, these are my 2 points. They're x and a. So how would I find the change in y? I would do f of x minus f of a. And then what would I do on the bottom? X minus a. So that's one of the formulas you can use. And then I'm going to write another one for you. Or the limit as h goes to 0, f of a plus h minus f of a over h. You can use either of these. And this one, I'm going to explain where this one comes from. They're the same thing. They're going to produce the same result. But in this one, do you see, here's my point A, and I'm going a little bit beyond A. Really, really little bit. Really close. Just scooting forward a tiny bit. So once again, I'm picking a point, or I'm picking a value that's going to get me a little bit ahead of A. And then that would be the y's over here. And then on the bottom, when you subtract them, you'd be left with h. Just h on the bottom. Okay. Questions? So let's use it then. And we're going to have to use some knowledge of algebra and some factoring and things like that. Okay? Andrew?
What?
What's the problem back there? Okay, let's do 2 examples, and then you can ask me some questions. We're gonna find f prime of 4 if f of x equals 2x squared minus 3. So, this is in the formula. This is my point. I want to do this right around 4. I'm trying to find this curve, if I were to graph it, and I plotted the point 4, I'm trying to find what's the slope of that line there, of that tangent line there, okay? So I'm going to use the second definition, and I'll put it up at the top so we don't forget what we're doing. And then I like to write down what we have to find. So we're going to do f of a plus h, so it's going to be f of 4 plus h minus f of 4 over h, because that's my A. So over on the side here, I'm going to write down my things. First of all, what's the problem right now if I tried to put in direct substitution? You have a 0. So what we're going to do is we're going to multiply this all out, and we're going to try to get the h's to cancel. That's the goal, right? So I'm going to write f of 4 first. That's not too bad. So what's 4 squared? It's 16, right? Times 2 minus 3. Okay. And then now let's write f of 4 plus h, and this is where you can't forget some things from algebra. What this means is I'm going to, in the formula, instead of x, I'm going to replace it with 4 plus h. So this is 2 parentheses 4 plus h squared minus 3. And 4 plus h squared is not 4 squared plus h squared. What is it? 4 plus h times 4 plus h. Okay? Alright, so let's, in our head, let's do that. 4 plus h times 4 plus h is, let's see, 16 plus 8h plus h squared. Okay? Now what should I do? Distribution. So we have 32 plus 16h plus 2h squared minus 3. And then can I add any like terms? 32 minus 3 is 29. Okay. to put that up there. F of 4 was 29. I'm going to put that up there over h. So here we go. This was my little algebra work. Often it's not the calculus that gets people in calculus, it's the algebra. It's like because you have to do all this other work to get to the limit. So I'm going to write f of 4 plus h. So what am I going to put in that spot? Good. 29 plus 16h plus 2h squared. And yep, minus f of 4. So then I have to write minus 29 all over h. And just maybe later on, just so you're clear what we're doing here, let's draw a little diagram. This is f of 4 plus h, because you might think, where is that stuff coming from? And this is f of 4. Okay. What happened? So these cancel, and do you notice these both have an h in them? Let's divide everything by h then. What's 16h divided by h? 16. And what's 2h squared divided by h? Plus 2h. Now can I evaluate the limit as h goes to 0? Yes. What happens when you put a 0 here? Cancels, get 16. So what I've just found is, if I were to graph this curve, I'll show you a sketch of what you just found. So here's the parabola 2x squared minus 3, okay? At the point 4, we'll say it's up here. At the point 4, this tangent line has a slope of 16. That's what I just found, the slope of that tangent. Okay? Questions so far on how I did that?